When determining the size of the bonding jumper for a jacuzzi motor connected to metal water piping, you need to refer to the correct section of the National Electrical Code. The applicable section for sizing the equipment grounding conductor, which includes bonding jumpers, is NEC section 250.122. This section provides specific guidelines based on the rating of the overcurrent protective device in the circuit. Section 250.66 pertains to grounding electrode conductors, which are different from equipment grounding conductors or bonding jumpers. Let's delve into the specifics of NEC section 250.122. This section outlines the minimum size requirements for equipment grounding conductors based on the rating of the overcurrent protective device protecting the circuit. The overcurrent protective device is usually a circuit breaker or fuse. To determine the correct size, you need to identify the ampacity of the overcurrent device protecting the jacuzzi motor circuit. Once you know the ampacity, you can consult Table 250.122 in the NEC. This table provides the minimum size of the equipment grounding conductor, including the bonding jumper, based on the overcurrent device rating. It is crucial to use the correct table and apply the appropriate ampacity of the overcurrent device to ensure that the bonding jumper is adequately sized for safety. For example, if the overcurrent protective device is rated at 20 amps, Table 250.122 might specify a minimum size of 12 American wire gauge copper or 10 American wire gauge aluminum for the equipment grounding conductor. Similarly, if the overcurrent device is rated at 30 amps, the table might specify 10 American wire gauge copper or 8 American wire gauge aluminum. The table continues to specify conductor sizes for higher overcurrent device ratings. The purpose of the bonding jumper is to provide a low impedance path for fault current to return to the source. This ensures that the overcurrent protective device will trip quickly in the event of a ground fault, minimizing the risk of electrical shock and equipment damage. Therefore, selecting the correct size of the bonding jumper is critical for safety. Incorrectly sized bonding jumpers can result in inadequate fault current carrying capacity, leading to delayed tripping of the overcurrent device and increased risk of electrical hazards. In addition to using Table 250.122, it's also important to consider other factors that may affect the size of the bonding jumper. These factors include the length of the conductor, the material of the conductor, and the ambient temperature. Longer conductors have higher impedance, which may require a larger conductor size to maintain adequate fault current carrying capacity. Similarly, aluminum conductors have higher resistance than copper conductors, so they may require a larger size for the same ampacity. High ambient temperatures can also reduce the ampacity of conductors, requiring a larger size to compensate. It is always a good practice to consult with a qualified electrical inspector or engineer to ensure that the bonding jumper is correctly sized for the specific application. They can help you navigate the complexities of the NEC and ensure that the electrical installation meets all applicable safety requirements. Keep in mind that local codes and regulations may also impose additional requirements for bonding jumpers. It is important to be aware of these requirements and comply with them to ensure that the electrical installation is safe and compliant. Regularly inspect the bonding jumper for any signs of damage or corrosion. Damaged or corroded bonding jumpers can lose their effectiveness and increase the risk of electrical hazards. If you find any damage or corrosion, replace the bonding jumper immediately. When installing the bonding jumper, make sure that it is securely connected to both the jacuzzi motor and the metal water piping. Use appropriate connectors and follow the manufacturer's instructions for proper installation. Poorly installed bonding jumpers can create high resistance connections, which can impede fault current flow and increase the risk of electrical hazards. Also, consider the environment in which the jacuzzi motor and water piping are located. If they are located in a wet or corrosive environment, use corrosion-resistant materials for the bonding jumper and connectors. This will help to prevent corrosion and ensure that the bonding jumper remains effective over time. Remember that the NEC is a minimum standard. In some cases, it may be necessary to use a larger bonding jumper than required by the NEC to ensure adequate safety. This may be necessary if the installation is subject to severe conditions or if there is a high risk of electrical shock. When in doubt, it is always best to err on the side of caution and use a larger bonding jumper. Furthermore, always ensure that all electrical work is performed by a qualified electrician. Electrical work can be dangerous, and it is important to have the necessary skills and knowledge to perform it safely. A qualified electrician will be familiar with the NEC and other applicable codes and regulations, and they will be able to ensure that the electrical installation is safe and compliant. To summarize, sizing the bonding jumper for a jacuzzi motor to metal water piping involves several steps. Firstly, identify the overcurrent protective device rating for the jacuzzi motor circuit. Secondly, consult Table 250.122 in the National Electrical Code to determine the minimum size of the equipment grounding conductor based on the overcurrent device rating. Thirdly, consider other factors that may affect the size of the bonding jumper, such as the length of the conductor, the material of the conductor, and the ambient temperature. Fourthly, consult with a qualified electrical inspector or engineer if you have any questions or concerns. And finally, always ensure that all electrical work is performed by a qualified electrician. Remember that safety is paramount, and it is important to take all necessary precautions to prevent electrical hazard. By following these steps, you can ensure that the bonding jumper is correctly sized and installed, providing a safe and reliable electrical connection for your jacuzzi motor. The equipment grounding conductor, including the bonding jumper, is essential for protecting people and equipment from electrical shock and fire hazards. It provides a low impedance path for fault current to return to the source, allowing the overcurrent protective device to trip quickly and safely. Without an effective equipment grounding system, fault current can flow through unintended paths such as metal enclosures or water pipes, creating a risk of electrical shock. Therefore, it is crucial to pay close attention to the design, installation, and maintenance of the equipment grounding system. The NEC provides detailed requirements for equipment grounding, and it is important to follow these requirements carefully. In addition to the specific requirements for bonding jumpers, the NEC also includes general requirements for equipment grounding, such as the requirement to bond all metal enclosures and equipment to the grounding system. This ensures that all metal parts are at the same potential, minimizing the risk of electrical shock. The NEC also requires that the equipment grounding conductor be sized according to the ampacity of the circuit conductors. This ensures that the equipment grounding conductor has sufficient capacity to carry fault current without overheating. It is important to note that the equipment grounding conductor is not the same as the neutral conductor. The neutral conductor is used to carry normal load current, while the equipment grounding conductor is only used to carry fault current. The neutral conductor is typically insulated, while the equipment grounding conductor is typically bare or green insulated. The equipment grounding conductor must be connected to the grounding electrode system, which provides a connection to earth. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes. The grounding electrode system must be properly sized and installed to ensure that it provides a low impedance path to earth. The NEC provides detailed requirements for grounding electrode systems, and it is important to follow these requirements carefully. In summary, equipment grounding is an essential part of any electrical system. It protects people and equipment from electrical shock and fire hazards by providing a low impedance path for fault current to return to the source. The NEC provides detailed requirements for equipment grounding, and it is important to follow these requirements carefully. By following these requirements, you can ensure that your electrical system is safe and reliable. Remember that electrical safety is everyone's responsibility. If you are not qualified to perform electrical work, it is best to leave it to a qualified electrician. Electrical work can be dangerous, and it is important to have the necessary skills and knowledge to perform it safely. A qualified electrician will be familiar with the NEC and other applicable codes and regulations, and they will be able to ensure that your electrical system is safe and compliant. Always double-check the specific requirements in your local jurisdiction, as they may have amendments or additions to the National Electrical Code. Consulting with a licensed electrical contractor is always advisable for any electrical work to ensure compliance and safety.